Hello student, welcome to the second part of the attention lecture video. And in this video, we will be continuing our discussion about this yellow highlighted topic from the directing attention by scanning a scene to attention and inspiring a coherent word. All right, guys, so as we might experience in our everyday life, so there are actually a lot of things that are potential object of our attention, right? But we attend to some things and ignore others. The question is, how do we accomplish this? How does directing our attention affect our experience? To answer that, we begin by considering how we can direct our attention by moving our eyes to look at one place after another. To gain more understanding about this phenomena, you can do this demonstration. Yeah, please take a look at this picture and try to count how many people in this picture. So as you did this task, you probably noticed that you had to scan the scene, right? To scan this picture, this scene of this picture, and checking each face in turn in order to identify it. Yeah. So scanning is actually necessary because good detailed vision occurs only for things you are looking at directly. So this task actually illustrates the difference between central vision, yeah, and peripheral vision. So central vision is the area that you are looking at, and the peripheral vision is everything off to the side. So because of the way the retina is constructed, objects in central vision fall on a small area called the fovea, as you might recall from your biopsychology class. Yeah. So the fovea, which has much better detail in vision than the peripheral retina, on which the rest of the scene fall. So thus, as you scan the scene in the previous figure in the previous slide, you were aiming at your fovea at one face after another. And each time you briefly paused at one face, you were making a fixation. Yeah. And then when you moved your eye to observe another face, you were making a saccadic eye movement, or a rapid jerky movement from one fixation to the next. So it is not surprising that you are moving your eyes from one place to another because you're trying to identify as many people as possible, right? But it might be surprise you to know that even when you are freely viewing an object or scene without searching for anything in particular, you move your eyes about 3 times per second. It's interesting. And shifting attention from one place to another by moving the eyes is called the overt attention, because we can see attentional shift by observing where the eyes are looking. So we will now consider two factors that determine how people shift their attention by moving their eyes is the bottom-up and top-down processing that we have learned before in our perception topic as well. And the first one is it's the stimulus salience, yeah, scanning based on the stimulus salience. And attention here actually can be influenced by the physical property of the stimulus here, such as the color, the contrast, or the movement. And capturing attention by stimulus salience is actually bottom-up processing, because it depends solely on the pattern of the light and dark and color and contrast in the stimulus. For example, the task of finding the people with, for example, like blonde hair, yeah, would involve bottom-up processing because it involves responding to the physical property of the color without considering the meaning of the image. Okay, and determining how salience influence the way that we can scan a scene typically involves analyzing characteristics such as color, orientation, intensity at each location in the scene, and then combining these values to create a saliency map of the scene. All right, another example, the person in the red, in this figure, in the red shirt, Yeah, both for the brightness of the color and because it contrasts with the expanse of white, which has lower salience because it is homogeneous. So experiments in which people's eyes were tracked as they observed picture have found that the first few fixations are more likely on high salience area. But after the first few fixation, scannings begin to influence the top-down or cognitive processing. That is depend on things such as the observer's goal and expectation and determined by the past experience in observing the environment, in which we will take a look closer in this example of experiment. Yeah, it illustrates the top-down processing because scanning is actually influenced by the preference of a person brings to the situation. Yeah, and the top-down processing also comes into play when scanning is influenced by the scene schema. It's the observer's knowledge about what is contained in the typical scenes. Yeah, and this is one example of experiment conducted by Foe and Henderson in 2009. They show pictures like the ones in this figure. An observer looked longer actually at the printer in this B part rather than the saucepan here in this A part. Yeah, because a printer is less likely to be found in kitchen. So people look longer at things that seem out of place in a scene because their attention is affected by their knowledge of what is usually found in the scene. And another directing attention by sending a scene is also conducted, also can be based on task demand. So this example is to demonstrate the knowledge of various characteristics of the environment that can influence how people direct their attention. So consider this example, the pattern of the eye movement in this figure shown by the ABC here is was measured as a person was making a peanut butter sandwich, and the process of making the sandwich begin with the movement of a slice of a bread from the bag is in the A and then to the plate or the B. And notice that this operation is accompanied by an eye movement from the bag to the plate. And the observer then looks at the peanut butter jar just before it is lifted and looks at the top just before it is removed. So attention here can shift then to the knife, which is picked up and used to scoop the peanut butter and spread it on the bread. So the person fixated on few objects or areas that were irrelevant to the task, and eye movement and fixation were closely linked to the action that the person was about to take. Yeah, and further, the eye movement usually preceded by motor action by a fraction of a second, as when the person first fixate on the peanut butter jar and then reach over to pick it up, yeah, and spread it to the bread. So this is an example of the just-in-time strategy. So eye movement occurs just before we need the information they will provide. All right, so and then we will continue our discussion about the outcomes of attention. What do we gain by attending? Right, so that's the question. So based on the last section, which described the offered attention that is associated with eye movement, yeah, we might answer that question by stating that shifting attention by moving our eyes enables us to see places of interest more clearly. This is extremely important because it places the things we're interested in front and center where they are easy to see. But then some researchers have approached attention not by measuring factors that influence eye movement, but by considering what happens when we shift our attention without making eye movement. So shifting attention while keeping the eye still is called as covered attention, because the attentional shift can be seen by observing the person. Yeah, and this type of attending involves shifting attention with the mind, as you might do when you're paying attention to something off to the side while still looking straight ahead. Yeah, this also has been known as looking out of the corner of your eye. Yeah. And one reason some researchers have studied covert attention is that it is a way of studying what is happening in the mind without the interference of eye movement. So we will now consider research on covert attention, which shows how shifting attention in the mind can affect how quickly we can respond to location and to objects and how we perceive the object. So Posner and their co-workers in 1978 here did an experiment. They asked whether paying attention to a location that will improve a person's ability to respond to stimuli that presented there. And to answer that question, Posner used a procedure called pre-cueing. Yeah. And the result of this experiment shown in this figure indicate that participants reacted to the square more rapidly when their attention was focused on the location where the signal was to appear. And Posner interpret this result as showing that information processing is more effective at the place where attention is directed. And this result and others like it give rise to the idea that attention is like spotlight or zoom lens, yeah, that improves processing when directed toward a particular location. All right. So in addition to covertly attending to location, as in Posner experiments, we can also covertly attend to specific objects. So we will now consider some experiments that show that. The first one is attention can enhance our response to object, and the second one, attention is directed to one place on an object. The enhancing effect of that attention then spread to other places on the object. So we can see from the example, an experiment conducted by Egli et al. In 1994. Here, participants kept their eyes on the plus symbol. One end of the rectangle was briefly highlighted, as you can see in this A figure. This was the cue signal that indicated where the target or the dark square in the figure B would probably appear. So in this example, the cue then indicates that the target is likely to appear in position A, yeah, at the upper part of the right rectangle, and the target is in fact presented at A. Yeah, the letter here used to illustrate the position in our description did not appear in the actual experiment, actually. Yeah, this is only a way to help us. So the participant task was to press a button when the target was presented anywhere on the display, yeah, and the numbers then indicate the reaction times in milliseconds, yeah, for 3 target locations when the cue signal had been presented at A. And not surprisingly, the participants here responded most rapidly when the target was presented at A when the cue had been presented, of course. However, the most interesting result is that participants responded more rapidly when the target was presented at B. So the reaction time is 358 milliseconds. Then when the target was presented at C, where the time is 374 milliseconds. So the question is, why does this occur? So it can be because B is closer to A than C, right? Because B and C are exactly the same distance from A. Rather, B's advantages occurs because it is located within the object that was receiving the participant attention. So attending at A, where the cue was presented, causes the maximum effect of A, but the effect of this attention spread throughout the object, so some enhancement occurs at B as well. Yes, interesting. So the faster responding that occurs when enhancement spread within an object is called the same object advantage. All right, moving on about the outcomes of attention. So many experiments have shown that attended objects were perceived to be bigger and faster, right? And to be more richly colored and have better contrast than non-attended objects. And also attention, therefore, here not only causes us to respond faster to location and objects, but also affect how we perceive the object. So attention and perception here, it's like really close relation. And the next outcome of attention is also has effects to physiological responding, because attention has a number of different effects on the brain, yeah, and it's already measured by some experiments. And one effect is to increase the activity in areas of the brain that represented the attended location. So as you can see in this example of experiment conducted by Dara and Deyoe in 2009, so attention to location here increases activity in specific areas of the brain. Yeah. To answer the question, what happens to the brain when people shift their attention to different locations while keeping their eyes stationary? And to answer that question, the researchers measuring brain activity using fMRI, as the participant kept their eyes fixed on the center of the display of this figure and shifted their attention to different locations in the display. And the color in the circles in this figure B here indicate the area of brain that was activated when the participant directed his or her attention to different locations indicated by the letters on the stimulus in the figure A here. As you can notice, the yellow hotspot in this picture, which is the place of the greatest activation, yeah, moves out from the center and also become larger as attention is directed farther from the center. So by collecting brain activation data for all the location on the stimulus, so the researcher here created attention maps that show how directing attention to a specific area of the space activates a specific area of the brain as well. And what makes this experiment even more interesting is that after attention maps were determined for a particular participant, that participant was told to direct his or her attention to a secret place, the unknown to the experimenters, yeah? And based on the location of the resulting yellow hotspot in the brain, the experimenter were able to predict with 100% accuracy the secret place where the participant was attending. All right, so another discussion that we will discuss also about the divided attention, yeah? The question is, can we attend to more than one thing at a time? Of course, the answer is yes, yeah, because the distribution of attention among two or more tasks can occur, yeah. People can simultaneously drive, have conversation, listen to music, and think about what they're going to be doing later that day, yeah. Also, this may not hold for difficult driving condition, but yeah, this you can do that. And as we will see, the ability to divide attention depends on a number of factors, including practice and difficulty of the task, which we will discuss using this experiment conducted by Snyder and Shiffrin in 1977, which involved divided attention, yeah, because they required the participants to carry out two tasks simultaneously. All right, sorry for the sound background, that's pretty annoying, but we shall continue right now. So here I want to continue to explain about Shiffrin and Snyder experiment in 1977. So the participant actually required to carry out two tasks simultaneously. The first one is holding information about target stimuli and in memory. And the second one, they should pay attention to a series of distractor stimuli, yeah, to determine whether one of the target stimuli is present among these distractor stimuli. All right, and the the participant was shown a memory set like the one in this figure, consisting of 1 to 4 character, yeah, and called as a target stimuli. And then the memory set was followed by a rapid presentation of 20 test frames, yeah, each of which contained distractor. Okay, and then on half of the trials, one of the frames contained a target stimulus from the memory set, and a new memory set was presented on each trial, so the targets changed from trial to trials, followed by a new test frame. So in this example, there is one target stimulus in the memory set. There are 4 stimuli in each frame, yeah, and the target stimulus 3 appears in one frame like this. At the beginning of the experiment, the participant performance was only 55% correct. So it took 900 trials for performance to reach 90%, yeah, as you can see in this figure. So the participant then reported that for the first 600 trials, they had to keep repeating the target item in each memory set in order to remember them. However, participant reported that after about 600 trials, the task had become automatic. As you can see, the frames appeared and participant responded without consciously thinking about it. And they would do this even when as many as 4 targets has been presented. What this means, according to Snyder and Schifrin, is that the practice made it possible for participants to divide their attention to deal with all the target and test items simultaneously. Furthermore, the many trial of practice then resulted in automatic processing, yeah, and a type of processing that occurs is without attention, or it happened automatically without the person intending to do this, and at a cost of only some of the person's cognitive resources. And let's continue from divided attention to distraction. As you may also aware that our environment is full of distraction, right? Or the things that direct our attention away from something that we are doing. And a source of distraction that has become widespread in these last few decades is the cell phone or other gadgets, yeah, like tablets, computer, yeah. And then also this distraction by the internet, as well as distraction by mind wandering, yeah. And one of the most dangerous consequences of the sources of distraction occurs while driving. So as you can see in this upper figure, here is the result of Schreier and Johnston in 2001 cell phone experiments. Yeah, so when participants were talking on a cell phone, they actually missed more red lights and took longer to apply the brakes of their car. Okay, so it is the example from research that actually phone is really dangerous for driving. And the distraction by internet, yeah, it's also quite common, yeah, and actually to be able to overcome the distraction by internet is based on the people's self-regulation or self-control, yeah, to develop a strategy of self-control, as we do with other every temptation in life. It's also including the internet, as well as the mind wandering or thought that coming from within, which also have been called daydreaming. It's also the source, the most common source of attention. All right, so one thing that should be clear from our discussion so far is that attention is actually precious, yeah, but it is actually also limited resources. So we can attend to something, but not to everything, yeah. And dividing attention is possible, but it's also difficult. And there are forces out there in the world trying to distract us from paying attention to what we're supposed to be attending to, right? Like some of the example of the distraction from previous slide. And when we don't attend, one phenomenon called as an intentional blindness, it illustrates how we can miss things even if they are clearly visible. Yeah, inattentional blindness here occurs when people are unaware of clearly visible stimuli if they are directing their attention to them. So you can see from the experiment done by Finch and Laffey in 2007, they had participants view the cross stimulus shown in this A figure, and the cross was presented for 5 trials, and then the observer's task was to indicate which arm of the briefly flashed cross was longer. Is the horizontal or the vertical? So this is a difficult task because the arms were just slightly different in length, and the cross was flashed rapidly, and the arm that was longer changed from trial to trial. On the 6th trial, a small outline of square then was added to the display, as you can see in this B figure. And immediately after the 6th trial, participants were asked whether they noticed if anything had appeared on the screen that they had not seen before. Out of 20 participants, only 2 who reported that they had seen the square. So from this experiment, most of the participants were blind to the small square, even though it was located right next to the cross, and it called as inattentional blindness. And the idea that inattention can cause us to miss visual stimuli has been extended to hearing. Yeah, so Raffey and Laffey, again in 2015, they conduct an experiment and they ask participants to carry out a visual search task where the visual search involves scanning a scene to find a specific object, yeah, like in this figure A. And the hard task is like the one in the figure B here. Yeah, participant also then asked to indicate whether they heard a tone that was presented during the visual display on about 1/5 of the trial. Again, the results shown in this figure C indicate that it was more difficult to detect the tone where engaged in the hard visual search task. Yeah. And this situation in which focusing on a difficult visual task result in impaired hearing is an example of inattentional deafness. Okay. And then researchers then have also demonstrated how a lack of attention can affect perception using a procedure called change detection, in which one picture is presented followed by another picture. And the task is to determine what the difference in between them. Yeah, so you may see this picture, this first picture, and then the second picture. Were you able to see what was the difference in this second picture compared to the first one? So people often have trouble detecting the change, even though it obviously when you know where to look, right? So try again, paying the attention again to this picture. Okay, compare to this picture and tell me if you can find the differences between this picture and this picture. Okay. So the question is, why does the change blindness occur? So the answer is that when we look at the scene in a still picture or at the ongoing action in a film, our attention is often not directed at the place where the change occurs, yeah, because we don't have the cue. And to continue that, we now consider yet another function of attention, and one that is not obvious from our everyday experience, yeah. And this function of attention is to help us create a binding, or the process by which features such as color, form, motion, and location are combined to create our perception of a coherent object. So, so for example, when you are sitting on a bench in the park, then appreciating the color of the leaves surrounding you, when all of a sudden a red ball, a sudden of red ball roll across your field of view and then followed closely by a small child chasing the ball. So when the ball rolls by, a number of different types of cells actually fire in your brain, and cell sensitivity to the ball surrounding shape fire in your temporal cortex, cells that is sensitive to movement and then fire in areas specialized for movement, and so on. Yeah, so your experience is actually integrated perception of a ball, with all of the ball's features being bound together to create the coherent perception of a rolling red ball. So the question of how an object's individual feature become bound together, which is called by the binding problem, has been addressed by Treisman in her research and called as feature integration theory. And according to theory of this theory, the first step in object processing is the pre-attentive stage. Yeah, it's occurs before we focus attention on an object. Yeah, because here attention is not involved. Then the researcher argued that this stage is actually automatic. Yeah, it's also unconscious and effortless. And in this stage, the feature of object are analyzed independently in separate area of the brain and are not yet associated with a specific object. Yeah, for example, during this pre-attentive stage, the visual system of person observing a rolling red ball will process the quality of the redness, the roundness, the movement separately. And then in the next in the next stage of processing called the focus attention stage, then attention is focused on the object and the independent features of the combine, causing the observer to become consciously aware of the rolling ball. Yeah. And in this two-stage process, you can think of visual features as component of a visual alphabet, for example, yeah. At the very beginning of the process, the information about each of these components exists independently of one another, just as the letter tiles in a game of Scrabble, yeah. It's exists in an individual unit, yeah. But then when it combined, then you can understand the words. And then happen at the focus attention stage as a combined features. All right, moving on to provide some perceptual evidence that objects are in fact analyzed into the features. Then Treisman and Smith conducted an experiment that involved a perceptual effect called illusory conjunction here, in which one object can take on properties of another object. Yeah, and the researchers presented display like the one in this left figure. In which 4 objects are flanked by 2 black numbers, 1 and 8, and they flash this display onto a screen for 1/5 of a second, followed by a random dot masking field designed to eliminate any residual perception that might remain after the stimuli were turned off. And then participants were told to report the black number first and then to report what they saw at each of the 4 locations where the shapes had been. Those participants had to divide their attention across 2 tasks, right? The first one identifying the number and the second one identifying the shapes. So by dividing participants' attention, the Treisman and Smith here reduced their ability to focus attention on the shape. So what did participants actually report seeing? Interestingly, on about 1/5 of the trial, the participant reported seeing shapes that were made of a combination of features from 2 different stimuli. For example, after being presented with the display in this left side, in which the small triangle is red and the small circle is green, they might report seeing a small red circle and small green triangle. So this combination of features from different stimuli are also called as illusory conjunction. So this illusory conjunction can occur even if the stimuli differ greatly in shape and size. For example, a small blue circle or a large green square might be seen as a large blue square and a small green circle. Although illusory conjunction are usually demonstrated in laboratory experiment, they can occur as well in other situations, yeah? So in a class demonstration, to illustrate that observers sometimes make errors in eyewitness testimony, so researchers had a male wearing a green shirt burst into the class and then grab a yellow purse that was sitting on the desk, yeah? So this like experiment happened so rapidly that it surprised the student in the class, and then whose task was to describe what had happened as eyewitness to a crime. So interestingly enough, one of the students reported that a male wearing a yellow shirt grabbed a green purse from the desk. So this interchanging of the colors of this object is an example of illusory conjunction. And according to Treisman, illusory conjunction here occurs because in the pre-attentive stage, each features exist independently of the others. That is, features such as redness or curvature or tilted line at this early stage of processing not associated with a specific object. They are free-floating. Yeah, in the researcher's word, it's called as free-floating. As you can see in this right hand figure, can therefore be incorrectly combined if there is more than one object, especially in the laboratory situation when briefly flash stimuli are followed by a masking field. Very interesting, right? And okay, class, it was the explanation about attention in our cognitive psychology lecture video today. Thank you for your attention, and I'll see you again.